Have you ever looked at a control panel drawing and felt completely lost? You are not alone. Many students, technicians, and even new engineers struggle to understand electrical drawings. In this video, I'll explain a simple step-by-step method to read any control panel drawing confidently. By the end of this video, you'll understand how to identify components, how to trace power circuits, how to read control circuits, how to follow wire numbers and terminal blocks. Let's get started. Step 1. Start with the title block. The first thing you should always check is the title block. It contains important information such as project name, panel name, drawing number, revision number, sheet number. This information helps ensure you are reading the correct and latest drawing. Step 2. Understand the drawing layout. Most control panel drawings are divided into power circuit. It shows how electrical power flows from source to load. Control circuit. It shows how the system operates and controls the load. Think of it this way. Power circuit equals to muscle and control circuit equals brain. Step 3. Identify major components. Before reading any circuit, identify the components. Common symbols and abbreviations include QF means circuit breaker, KM means contactor, ALL means overload relay, M means motor, PB means push button, TR means timer relay, TB means terminal block, H means indication lamp. Understanding these symbols makes reading the drawing much easier. Step 4. Follow the power circuit. Now let's trace the power flow. A typical motor control circuit looks like this: incoming supply, to circuit breaker, to contactor, to overload relay, to motor. The power circuit tells us how electrical energy reaches the motor. Whenever troubleshooting, start by checking this path. Step 5. Read the control circuit. The control circuit tells us how the motor starts and stops. Typical components include stop push button, normally closed, start push button, normally open, contactor coil, auxiliary contact. When start is pressed, contactor coil energizes. Main contacts close. Motor starts running. When stop is pressed, coil energizes. Motor stops. This is the basic principle behind most motor control circuits. Step 6. Understand wire number. Every wire in the drawing has a unique number. Example, 101, 102, 103. These numbers help technicians trace connections easily. If wire 102 appears elsewhere in the drawing, it's the same electrical connection. Wire numbering is extremely important during commissioning and troubleshooting. Step 7. Read terminal blocks. Terminal blocks connect panel wiring to field devices. Examples, TB1:1, TB1:2, TB1:3. These references tell you exactly where field wires should be connected. Whenever you're wiring a panel, terminal blocks are your best friend. Step 8. Understand cross-references. Large panels require multiple drawing sheets. You may see references such as, continue on sheet 5. Refer to page 8. Wire continues at grid. These references help you follow circuits across different pages. Step 9. Understand PLC inputs and outputs. In modern panels, you'll often see PLC drawings. Inputs, push buttons, sensors, limit switches, pressure switches. Outputs, contactors, solenoid valves, indication lamps, relays. Always identify whether a device is an input or output. Practical example. Imagine a Dole starter panel. Power circuit. Supply to MCCB to contactor to overload to motor. Control circuit. Stop PB to start PB to contactor coil. When start is pressed, coil energizes. Contactor closes. Motor starts. When stop is pressed, coil energizes. Motor stops. This simple logic forms the basis of most industrial motor control systems. Conclusion. To read any control panel drawing, remember these 6 steps. Check the title block. Identify components. Follow the power circuit. Follow the control circuit. Trace wire numbers. Check terminal connections. Master these basics and you'll be able to understand most industrial control panel drawings with confidence. If you found this video helpful, don't forget to like, share, and subscribe to my channel for more practical electrical engineering content. Comment below, which electrical drawing topic would you like to learn next?